Okay, now that I've started recording, we'll go ahead and start the class. Whoops. Okay, now that I've got my headset in, we can go ahead and start the class. So today's lecture is going to focus more on lists, and we're going to add a little bit about strings as well, because strings in some ways are like lists. Strings are not lists, but they're kind of like them a little bit. So we're going to talk about some things you can do. Remember that homework 2 is due tonight at midnight. I've had a number of questions, a number of people having issues with a couple of specific things. So as a result, there's one thing I want to go over on the next slide, and we'll talk about it. The next line is live for another 90 minutes. Homework 3 will be out right after class. I haven't finished editing it. It will be the same as the majors' homework 3 with, I think, one minor change. It will be due next Monday, the 28th, according to my calendar. If that religious observance is an issue for you, let me know, and we can work in an extension or something else. So, like I said, that'll be out right now. I just failed to get it up on the GitHub before class started, so I will get that out. In terms of planning, test 1 is currently scheduled for Wednesday, October 7th. That's about 2 weeks from now, and a little over 2 weeks. We will be different from the majors in the following way. Monday, October the 5th, that lecture will be a review day. Test for our class will be on Blackboard in real time. You will log into Blackboard and you will have 90 minutes to complete the test. It will be open book. You can Google, you can run stuff on PyCharm, you can do whatever you want. About a week beforehand, so probably next Wednesday, Thursday-ish, I'm going to put a practice test on Blackboard. That'll be the same type and number of problems, the same length, so you can get the feel for what it's like to take one of my exams on Blackboard. And then among other things on that review day, the 5th of October, I will go over that practice test and we can talk about things, anything you're not clear about, what have you. I will monitor the text on Blackboard. We'll go over this again, but on the 7th, I will be live on WebEx in case you have any questions, something isn't clear, or you're having a problem, what have you. So this is for planning purposes. The majors' classes do a little bit on Blackboard, but theirs is mainly a take-home test. They have 3 to 4 days. It's essentially like a programming assignment. I don't like that. I just prefer doing it in the 90 minutes. We do not use any lockdown browsers. We do not use Respondus. We do not use any of that, pardon me, silliness. So you just have 90 minutes and whatever resources you want to use to solve the problems. Again, today's lecture is going to be more about lists and a little bit about strings. Strings are not lists, but sometimes they're treated like it. And then Wednesday's lectures on for loops, the homework you're going to do on lists are useful when you have loops, and the homework you're going to do on this week relies on loops. So after Wednesday, you should be ready to go and able to do that. With that being said, one thing I want to do is talk a little bit about homework and homework 2, and there's one issue that one question seems to be bothering a number of students. It's the one where you're told the user's going to input certain values. You're going to enter a number 1 through 12 for a first knob. You have to be able to read it in and convert it to an integer. Remember that anything you read in with input, it comes in as a string. So you have to read in the first knob, and you have to make sure it's between 1 and 12 inclusive. And then you get a second knob, and it's between 1 and 12 inclusive. And a switch, which is either up or down. And you're given a set of rules. And so what I have done here is gone through and taken the pseudocode, the English text, and tried to clarify what's expected by listing 8 different cases. You have a first knob, which can be either an even number or an odd number. If it's an even number, it doesn't matter if it's 4, 6, 8, 10, it's an even number. The second knob, which can be even or odd, and a switch, which can be up or down. These are all the valid inputs for your program. So we have 8 cases in our truth table, and in those we've shown what the result is supposed to be. If the first knob's odd, the second knob is odd, and the switch is up, your result is the door clanks. There's a long phrase, but I just typed in 1 or 2 words to clarify that. Now, what we have to do, what you have to do in homework 2, is write the actual Python code that implements this truth table. You're not going to write the table. This table is just another form of pseudocode that's maybe a little bit clearer than the text that we give you right now. You're going to write Python that implements this. So let's talk about how you would do that. There's any number of ways to do it, really. But an easy way is there's only one case out of the 8 where the door opens, and that's if the first knob is even and the second knob is odd and the switch is up. Now, let's think about what kind of code we can do to test that case. Okay, what we want to do is test this case where we're talking even, odd, and up, and then the door opens. Okay, now if the first knob is even, this is where modular arithmetic comes into play. Okay, if it's even, then if you take the number mod 2, the remainder when you divide the number by 2, that's 0. So if first knob mod 2 is 0, and remember, it's equal, equal, not a single equal. That's an assignment. Pardon me, I left out the parts that I talked about, but left it out. Mod 2 is equal to 0. And the second knob, now to be odd, that's equal 1. The mod is equal to 1. That's odd. And the switch just equals the string up. Okay, so that's our case. So really what you need is you need this code, right? You need something like this that says if the first knob mod 2 equals 0, again, we presume you've converted it to integer, and that's just casting the string to integer. And the second knob mod 2 is 1, means it's odd, and the switch is up. And then at this point, you're going to print some message about the door opens. Okay. Now, we have taken care of case 5. So let me mark that by switching it to a different color. It's taken care of. Now, I've got 5 cases where the door clanks but doesn't open, and I've got 2 cases where the door doesn't budge. I can write the next case statement either way. I can address the 5 first, or I can address the 2 first. It just seems easier to me to address the 2 first, so we'll do that. Here are the only 2 cases where the door does not budge at all. The first knob's odd, the second knob's even, the switch is up. That's 3. The first knob's odd, the second knob's even, the switch is down. Okay? So I can look at those 2 cases in that table, and I can see that in both of them, the common factor is that first knob is odd and second knob is even, and it really doesn't matter what switch is. Switch can be either up or down, and I get the same results. So now in my code, I'll come over to this, and I'll put in an elif. We really don't want you to write if. That's kind of silly. You need to show mastery of Python, and you have an elif statement. Now, what's the 2 cases that we just talked about that. Covers the door, doesn't budge. Well, so if first knob mod 2 equals 1, that's odd, right? And second knob mod 2 equals 0, that's even. That's all I need. That's the only case. Then I print out some message about doesn't budge. Okay. And so now I'm going to mark in my truth table that I've covered these two cases by changing the coloring of them to something else. And now I just have these other 5 cases. And in all those cases, the door just clanks. The handle clanks. It doesn't open. Okay. Now I can try to figure out odd, 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 even, even, up, down, etc. But it doesn't matter. Right? In this case, everything else, every other possible combination returns the same thing. And so now I just need to write an else statement that says print whatever your clank message is. So if you're having trouble with that problem on homework 2, I wanted to work through it. This is the core of your code. Now, obviously, I'm not giving you the whole answer to the solution or the whole answer to the problem. Okay. This is a solution. If you have solved the problem the other way, any other way, any different way, and your code works, that's fine. Don't change it. I'm just illustrating one possible way to solve the problem. Okay. But if the text, the English text, the pseudocode is giving you problems and you really want to make sure that it's working right, you can build this truth table. The truth table is just another form of pseudocode. This is the pseudocode. This is the Python code that will run and implement a table like this. Now, obviously, this is not a complete program. You're going to have to do a lot of checking. You're going to have to do some other things to make the program work. I'm not giving you the answer to the problem straight out. And under the integrity rules, for clarification, any code I give you, you may use. It is not cheating to use anything I give you. If you do this on your own completely, that's fine. You are permitted to use anything I give you. So this is just intended as a little helper, since I know I've had a number of students having issues with this particular problem on the homework because maybe the pseudocode, the English pseudocode wasn't clear, or there's a number of different problems people are having. This is just illustrative. This is just an example of how you can solve it. Write out the truth table, identify all the cases, look for commonality in the cases. There's only one where the door opens. That's easy. It has to meet all 3 conditions. There's only 2 where it doesn't budge. That's easy. These things are in common. Nothing else is in that case, and we're good. And then everything else falls into an else. So that's what I'm trying to do here. Okay, so if you have any other questions on homework 2, at the end of class, we can get to it. Or this evening, I should be available off and on. You have until midnight. Submit it. If you don't have everything working on homework 2, please submit before midnight anyway. It is better to get a 30 or a 35 out of 50 than to get a 0. And remember, you can submit multiple times. So if you've got some of it working and you think you've got about a 30 or 35 pointer, submit it and then keep working on it. And you may get it later tonight completely working, and then you can submit it again. That's always okay. You can submit multiple times and only the last one's graded. So anyway, that was a point I wanted to cover on homework 2 again, because I'm getting a lot of questions, which is good. I'm here to answer questions. This is why I'm here. Okay. With that being said, let's have a quick review of what we talked about last Wednesday about lists in Python, and then we'll extend it. Lists. List is a fundamental type in Python. It contains 0 or more values. Okay, you can have a list of 0 values. That's an empty list, and we showed that last time. We sort of danced around the issue last time The elements of a list do not have to be of the same type. And later on in class, we will get into cases where that's important. You can have a list that contains a string, an integer, a real number, another string, another integer, and another string. And those are useful and meaningful. The problem is you have to be very careful when you start doing that. When you start building lists that have different types of the elements, that you have strings and integers all mixed in, you have to think very carefully about that. You can make it a lot harder to write your program. You can make your program harder to understand, and you can make it difficult, if impossible, to debug if you start arbitrarily mixing types. So you can do it. There are places where you will do it, but you should, do it on purpose, not because you think it's easy. Okay, we talked last time. There are two new lists. There are two ways to declare a new list. You can declare a new empty list. It's just a set of square brackets with nothing in between. This, boy, the Google Slides doesn't make that easy to read. That is just a pair of square brackets with nothing in between them. Okay, that's not some kind of funky box. That is a new empty list. That is a list with 0 elements. Or you can declare a new list that has initial values. I can declare a list of grades with integers 98, 94, 152, 93. So the first case, we just declared an empty list. The second case, we declared a list with initial values in it. Either one is valid, and how you do it depends on how your program works. You can add a new value to a list by using the methods .append or .insert. Okay? They apply to a list and they return a modified list. .append puts the new value at the end of the existing list. .insert takes both a value and an index, and it puts the new value at the index you specify, and it moves everything after that in the list down one place in the list. The index increases by 1 for every value after where you insert. Okay? Remember, though, that the first element of the list always has index 0. So if we say insert at index 4, that doesn't mean this is going to be the 4th element in the list. The element at index 4 is always the 5th element in the list. Okay? Then we have a function that returns the length of a list, the number of elements, and this is going to be an integer. The last element in the list will have index length of list -1. Now let me switch to PyCharm and illustrate a couple of things. Here in PyCharm, I've defined a list, predefined. There's actually a function in Python that does this for you, but here are the 50 states in the United States. So I have a single list that consists of 50 strings. Let's execute it so we're ready to go. And I can verify that I didn't miss any by asking what's the length of the list of states. That's 50. Actually, what happened was I typed them all in. I wanted them in alphabetical order, but I don't necessarily know them in alphabetical order. I learn them geographically. I can start at Maine, go from Maine, New Hampshire, Vermont, Massachusetts, Rhode Island, Connecticut, New York, and so on, and I can do them geographically, and I'll never miss one. If I do them alphabetically, I'll leave a couple out. So I did length, so I had 48, and then figured out which 2 I forgot. Okay. Now, what I want to do is look at the first element in the list. So what is states sub 0? And state sub 0 is the first state, Alabama. What is states sub 49? That's the last element in the list. And that's Wyoming. Okay. Even though we all know there are 50 states, we learned this. If I ask, what is the 50th state? That is an error, because index 50 would be the 51st state. And while people are trying to date, there is no 51st state. So that is an index out of range error. That is a semantic error in Python. List out of range, and this will happen to you a lot. Remember that if we want to be guaranteed to get the last element in the list, states sub the length of states minus 1. Length of states minus 1 is going to be 49 because we know that the length of states is 50. So length of states is 50 minus 1 is 49. So states sub 49 is Wyoming. Okay, because again, length of states minus 1 is 49. So state sub 49 is Wyoming. We can be lazy and take the shortcut, and instead of saying states sub length minus 1, we can simply say states sub minus 1. And that is the same thing. So we can start at the end and we can work our way backwards using minus 1, minus 2. If I want to ask what is state sub minus 20, that's New Mexico. Okay, so I can go forwards and backwards. Python is quite happy to do that. So let's go back to the slides. That's what we've just talked about here. Now, there was something, let's see, when I get to it, that I completely botched last time. Ah, yes, this is it. This is the next item. I completely botched this discussion last time. So let's go over and let's do it right. I did talk about remove, and remove is correct. My remove example was correct. Let's not mess with our list of states right now. Let's declare a new list, which is a list of A, B, C, D, E. Okay, so this is a list. And let's execute it. Okay, let's fix that. Okay. Again, debugging in real time is just a skill you eventually have to build up. Okay, now I have this list. If I want to remove the value A, then I say new list dot remove A. And now I see I have the list B, C, D, and E. But what if my original list had 2 copies of A in it? Now I remove A, and we'll notice that this only got rid of the first A. Okay, so you can only get rid of one value at a time with a remove statement. Pardon me. Apologies, I'm drinking iced tea and just had some go down the wrong pipe. Okay. If I tried to, and this is important, remove an element that's not there, I get an error message and my program crashes. It dies a horrible screaming death. And while we're letting you do that in the current programming assignments, that's not a good thing to do in practice long term. You want your program to be resilient. Users are going to input really bad things, either because they're trolls or because they just don't know what you want. And so it's best if your program not crash. So we'll talk about how to be robust about that. But for now, if you try to remove a value that wasn't there, you get an error. Now, here's what I botched. If we want to remove an element, not by its value, but by its list index, we have to use a method called pop. So let's look again at what's in new list. And let's suppose we want to remove this D. Okay, the D is at index 0, 1, 2. So if I want to get rid of the element at index 2, then I say new list dot pop 2. Now that returns the D if I want to use the D for something. And it gives me a modified list that has the D gone. So last time I tried to explain how to do this, and as I said, I completely messed it up, so ignore what I told you about that. If you want to remove an object from a list by its value, that's what remove is for. If you want to remove an object from a list by its index, you would use pop. Pop removes the index, and obviously it can only pop can only remove one element, and remove removes one element, the first one that matches. If you want to remove multiple items from your list at the same time, you use a function called del, short for delete. And so let's say I want to get rid of the C and the E. I want to keep the B and the A. I want to get rid of the C and E from this list for some reason. Okay, this is element number 1, index 1. This is 0. The C is 1. The E is 2. The A is 3. What I'm going to do in Python is say delete del from the variable new list. I have to tell which, I may have multiple lists in my program. I have to tell Python which list I want to get rid of stuff from. Delete new list from 1 to 3. Now, this is weird, so let me explain this. First, I'm going to illustrate it. And I'll show you that after I've done it, I got rid of the C and the E. I kept the B and the A. The significance of the numbers inside the square brackets is as follows. The first number, 1, this is the first list element I want deleted. I do not want element 0 deleted. I want element 1 deleted. Start deleting at element 1. Now, I don't say go through the last element, delete it. This is just a Pythonism. It's Pythonic. I'm not sure why, but it is. This second number is the first index I'm going to keep. This is not the last element to be deleted. This is the first one to keep. So this says start deleting at 1 and delete everything until you get to 3. So B is 0. Don't delete that. C is 1. Start deleting. E is 2. Keep deleting. A is 3. This is the first one to keep according to this statement. Okay? So this is the first one to keep, and you do that. So delete 1 to 3 says get rid of starting at 1, and 3 is the first thing you keep. And that's why we wind up with this result after that delete. Okay, so what we've gone over here is we have a way to remove an element by its value. And for that, we use the remove method. We have a way to get rid of one element by its index, and that we do with the pop method. And we have a way to get rid of multiple values by their index, and that's the delete function, or del. We do not have an easy way to remove multiple elements by their value. For that, we'd have to use for loops. We'll talk about it on Wednesday. There's no built-in method for doing it. Okay? A couple of things about these numbers. Just a little bit of confusion. You'll get a lot of practice with this. This is a common thing. If I don't give a first number, if I say delete new list, just :1, if I don't give a first number, that says start at 0. I could say start at 0, it doesn't matter. I can leave it out and say it, save a keystroke by just saying don't do anything. This starts at 0. 1 is the first thing we'll keep, so we'll have A left after we execute this. Okay, and just to validate that I haven't messed up again, all we have left is A. So if the first value is blank, is missing before the colon, that's a start at the beginning. If the last value is missing, that says go to the end and delete everything. So let's go back and have a non-trivial list. Let's start with this big list. Okay. And now we're going to delete, and it'll help if I spell it right, from 3 to the end. This says I don't have to count till the end. I just want everything gone from 3 on. So 0, 1, 2. In this case, the D, the E, and the second A are going to be gone when I execute this. And that's why I have the A, B, and C left. I could easily say delete from 3 to -1, and it would have had the same effect. Okay. Start with the same list. And I could say delete from 3 to -1, and it would have the same impact as the other one. Oh, no, I take that back. Because it says keep the element at -1, you have to use this form. If you want everything gone after that, let me correct my statement. If you want everything gone after this, you have to use this form where this is just to the end. Okay. So let's go back to the slides. Removing popping, like I said, I botched this last time, so I want to make sure I clarify it. To remove an item by its value, use remove. To remove it by its index, one at a time, use the pop method. Okay. If you want to delete, you use the delete function. Did I have an error in this slide? Yes. I can't believe I did this. Oh, yes, never mind. This is correct. If you want to get this is I had a sub bullet that says remove under pop. That's what I was trying to keep this up. Okay. All right. So my slide is correct. Remove, pop, delete. Okay. And I give another example in the code here. The note here, pay attention to this because it's going to keep this element right here. That's not the last one you get rid of. It's the first one you keep. And these are my notes about starting from the beginning and going to the end if you don't give a number. Okay, we sort of talked quickly about this last time, but I was running out of time, so I want to go into this. There is a function which returns a Boolean in Python called in. In is used anytime you want to find out if an element is in a list. Okay, and my comment here, we have this list. I called it my list here. It's new list in PyCharm. If I try to remove an element that is not there, my program crashes. My program dies a horrible screaming death. The user gets a nasty error message and thinks you're probably not a very good programmer. You know, for now, we sort of let you go, but in reality, we don't want to do that. So what you can do to make your program robust, what you can use to be a real computer scientist is the in statement. You can say if F in my list.remove, else print couldn't remove non-existent value from a list. Okay, so let's go back to PyCharm. Let's start over with our new list. Now, F in new list. This is a Boolean. It returns the reserved word, the Boolean value false. A in new list is a Boolean. It returns the Boolean value true because, of course, there are actually two A's in new list. And so what I can do is I can say, and on the slide, this is what I have. If F in new list dot remove F, else print some error message. Can't remove non-existent value from list. And I run that and I see I get the error message printed out, not remove. So in this case, it's better all the way around. We let the user know there's an error here, but we're not crashing the program for the error. We're continuing to move on and maybe can do something else. Now, if I had said instead, A, all right, what did I do wrong? I didn't fix everything. That's why. There we go. It appears that it worked, and I can just check the first A is gone. So the point of the in function is it lets us determine if something is present so that we don't do weird things and get strange errors and program crashing. In is a function. It returns a Boolean value. In will always return either true or false. Okay. And we can use it, as I said, as illustrated here and as illustrated in the slides to make sure that our program doesn't crash because we try to remove an element that's not there. Okay. And we can do this with other functions as well. Now, list slicing. Let's go back to my list of states and see if we can get just a subset of them. So I've still got states in here, I believe. Let me double check the states. States is defined. It's a long list. Okay. What if I wanted to do something with the first 10 states? Okay. How would I do that? Well, just like we can use those numbers with a colon for delete, we could use them to access elements of the list for whatever. The first element of the list is simply states sub 0. That's Alabama. We already know that. The 9th element of the list is the 10th state in the list, the one that is at index 9, the 10th state in the list is Georgia. So if I want the first 10 states, how would I reference them? Here is what I would do. I would say first states, it's going to be a new variable, is equal to states from 0. And let's watch this carefully. Let's make sure we understand it. 0 to 10. Okay, this is a perfectly valid assignment statement. I'll save a copy of this so we have it when I post them on GitHub. Okay. What is the value of first states? I have Alabama, Alaska, Arizona, etc., up through Georgia. So I have the old values 0 through 9. So I copied states 0 through 9. Remember, states sub 9 is Georgia. First states sub 9 is Georgia. And that's the last element in first states. So understand, confusing. But here's the thing to pay attention to. Just like with the delete, when I start indexing using these numbers, this is the first one I want to get to, whether I want to delete it, copy it, print it, or do whatever. This is the first thing I want to get to. This is the first one I don't include. When I was using the delete function, when I was using del, this number was the first one I didn't delete. When I copied it, this number was the first one I didn't copy it. If I print them, I'm going to print those 10 values, stopping at Georgia. 10 is the first one I don't print. So it can be confusing. I realize that. We'll just practice our way through it. The bottom line is when you give these indices, the first one, the one before the colon, is the first one you want to start with. The second number, the one after the colon, is the first one you do not include. Do not include state 10, which would be the one after Georgia, which is Hawaii. Okay? I don't have to do this from 0 to 10. I can do the same thing, states 21 to 30. Now, what this is going to do is going to start at element number 21, the 22nd state in alphabetical order. It is not going to include 30. 30 will not be included. So I'm actually only going to get 9 states by using this. By using 21 through 30, I'm going to get 9 states, 21, 22, 23, 24, 25, 26, 27, 28, and 29, because 30 is not included. So let's run this and find out why I didn't print. There we go. And it turns out 21 through 30 are Michigan, Minnesota, etc., up through New Jersey. Okay, so I can access any part of the list. Again, just as with the delete command, if I leave out a number before the first one, before the colon, if I leave out that first number, it starts at the beginning. That is going to have exactly the same impact as putting a 0 first. It starts at Alabama. It starts the same one. If I leave out the second number, it's going to go to the end. So this statement, because there's nothing after the colon, is going to go all the way to the end, and it will print out everything through Wyoming. And we can verify that it does that. Okay. So this whole thing, everything we've been doing, taking parts of the list, is called list slicing. List slicing. List slicing is a term for you have a list and you want some elements from the list, but not all of them. You slice the list. The index numbers are also called subscripts. So you'll see subscripts a lot. The index, the subscript, whatever you want to choose. It means the same thing. So these are examples of what I did. Screen caps, states 0 through 10 are the ones we printed out. This is 20 through 30, which is why it starts at Massachusetts, not Michigan. In what I did on PyCharm, I started with 21. This is 20, which is why you include Massachusetts. But again, it ends at New Jersey because index number 30, which would be New York, is not included. And then I can also go from the negative. If I go minus 20, it starts at the end and gives me 20 of them. Okay. So if you give the list variable name, square brackets, subscripts, separate with a colon, this is the stuff we've already talked about. Okay. So that is how you access elements from a list. You can slice it. So we've talked about appending, we've talked about inserting, we've talked about removing, deleting, popping. We've talked about slicing to get some of the elements, all the things you can do with a list. And on Wednesday, we'll talk about running loops so you can get them one at a time or 10 at a time or whatever. My dogs are having a field day playing, by the way. I have one and my daughter has one and they're two here and they really like being around for some reason, but they're okay. Strings. Strings are not lists, but sometimes you can do some of the same things to strings that you can do to lists. Now, the difference between a string and a list, and we're going to get into more of this later in the semester, but a string is a unitary item. It is not a group of things. A list is a group of 0 or more items. This list of states had 50 elements. The list of grades had 4 elements. The list I was playing with in PyCharm had 6 or 7 elements, depending on how many I deleted. Okay. But a string is one item. Now it has a length, it has a certain number of characters in it, but it's a unitary item. But what can you do with a string? Well, it turns out you can actually get the value of a particular character or set of characters in the string by using the index or subscript, the same as you can do with a list. Okay, so let's go back to PyCharm for just a minute. And in PyCharm, let's say that state name equals New York. I can use the length function, and the length of state name is going to be 8. Python is going to tell me that the variable state name, which equals the string New York, the single quotes don't count, that just indicates it's a string, has 8 characters in it. 1, 2, the E's 2, the W's 3, the blank space is 4. There's exactly 1 blank space here. The Y is 5, 6, 7, 8. There's 8 characters in there. But I can access part of the value, the string value, using an index or a subscript, just like with lists, and we start counting at 0. So if I say state name sub 0, what is the first letter, the first character in the variable state name? That is New York. What is the last character in state name? That's the K. Now, what about in? What I'm looking for here is to see if a blank space is in the variable state name. This, quote, blank space, quote, is just a blank space. Is there a blank space in the variable state name? That is true, because the way I have written it, there's a blank space between the new and the York. And so there is indeed a blank space in the variables, in the value of state name, the blank space between new and York. So just like with lists, I can access elements of the string by using their index or subscript. I can use the in function as a Boolean to determine a character is there or a string of characters. What if I want to take the state name and see if the string new, is this one of the states that has the word new in it? That still works. I can check to see if any arbitrary string is in my string variable, and it will return true if that exists, and it will return false. This is not Old York, this is New York. It's a Boolean function, it returns false. So strings, going back to our slides, just like with lists, I can use in, I can get values, I can do certain things. Does in work? Yep, sure does. Do dot append or dot insert work? Nope. Remove, pop, or del? Nope. Right after the first exam, when we get in the middle of the course, we're going to explain in hideous detail why. It's a fundamental property of the language called mutability. But for now, they do not work. If you tried to say state name dot remove n, Python would tell you, I'm sorry, this is not a list. You cannot remove a letter from a string. We know there's an n there. We know this is not the case of a wrong value, but we cannot apply remove. Similarly, we can't add a letter. If I tried to say state name dot append exclamation point, nope, sorry, can't append either. So those are just illustrations of what I have in the slide. In works, length works, in works, append and insert, remove, pop, and delete. Those do not work. Strings are not really lists. You can't do anything like that with them. What other things can you do? Well, you can split a sentence into a word, into a list. Python is very nice. Okay. Suppose I had this sentence, and I'm going to have to edit it. But let's go to PyCharm. I have to fix the double quotes never copyright. The reason is that even in Google Slides, they're smart quotes, and Python does not recognize the character. It's a different UTF-8 character. It's a different binary code for smart quotes. For regular quotes, Python doesn't recognize it, and so it throws an error that says, this is not a string, be real. Okay. Now, if I want to split that, I can simply say sentence.split. Now, splitting a sentence takes a string, this is a single string, and returns a list of strings. This is a list. You can tell by the square brackets that it's a list. And each element in the list is a string. You can tell by the quotes. This is an element. Elements are separated by commas. Each one has quotes around them. So I have taken a single string and I have split it into a list of strings. Now, where did it split? It split on what is called white space. White space, by definition in Python, is one or more blank spaces. It is a tab, or it is a new line character. Okay, so let's go back to our sentence and put a tab in there. Okay, so you may have to do it this way. We'll do it this way. Now you can see we have a tab in the middle of our sentence. We do sentence.split, and we get exactly the same result. Because to Python, white space is white space. Python, in this case, doesn't care about the holy war between spaces and tabs. Python says it's white space. I'm going to get rid of it. Okay, and that is the split function. It takes a string and it breaks it up into its component parts. By default, it does it at white space. Now, it does not have to split it at white space. You can tell sentence.split to split when you see a D. Every time you see a D, split the sentence. If you put nothing here, the default behavior is split it at white space. If you want to split your string on something other than white space, you have to tell it, I'm going to split this sentence every time I see a new D. Here's what it is. It took this and it says, hey, blank space. Now it kept the blank space. Here, the blank spaces got eaten up. They got consumed. Here, we weren't splitting on white space, so the blank space got kept. I saw a D, so that says split. Start a new thing with I, a new element with I. Then in this word, there's a D, there's more Ds. It said, okay, there's only an I. That's the end of that list element. Then I have two Ds to get rid of because there's two in a row. It actually produces an empty string. Then the LE space. Then it had to do the same thing. It had to get rid of this D. It took the I by itself. It had two Ds in a row it had to get rid of, so it gave you a blank space to indicate. Now, there's a long time before another D. After this one, we have to go all the way to the end of AND to get another D, so that becomes one element in the list, one string. Okay, and then again, nothing until these Ds in fiddle. Now, this is something you probably won't do, but you can. Most commonly used with split is split breaks it up on white space unless you tell it otherwise. And for now, when we get into where it's useful to split on something other than white space, we'll go into that in more detail. For now, what you need to know is you can. For now, what you need is the default behavior is we split on white space. White space is a space, a string, or a space, a tab, or a new line, and it breaks it up into a list. Another operation you can use on string is called strip. If you have a lot of white space, if you have a lot of empty characters, spaces, tabs, whatever, in your variable or in your string, and you want to get rid of, Kansas City did not actually play San Francisco. This is from a game last fall. Notice I have a lot of white space. And so when I come down here, score has a lot of white space. And I may not want that. I don't care about leading blanks. Who cares about leading blanks? It's not something I want to do. So there is a function built in, a method built into Python called strip that gets rid of white space for you. If I say score.strip, that gets rid of the leading white space, and that gets rid of the trailing white space. Now, conveniently, strip does not get rid of the internal white space, so I keep the spaces here between the KC and the 31 and the San Francisco and the 20 and so on. I don't want to lose those. The authors of Python said, no, you probably want to keep those. So strip gets rid of the leading and the trailing. Now, if you only want to get rid of some, let's say I just want to get rid of leading white space and I don't care about trailing white space, I can keep it. Leading is on the left side. That's an L. So the function to do that, the method to do that is lstrip, score.lstrip. Okay, L for left for leading. This will get rid of the white space on the beginning, but not on the end. Notice here, these leading spaces are gone. The trailing spaces are still there. Sometimes you just want to get rid of the leading white space, not the end. Sometimes it's the other way. Sometimes you want to get rid of the trailing white space, but let the leading white space stay there so you can line columns up. Yeah, you might want to do, there's better ways to line columns up, but you might want to do that. So the opposite of left strip is right strip. So we say score.rstrip. That says get rid of the white space on the right And you can see that white space is now gone. We kept the leading one. So going back to our slides, things you can do with strings. You can split them. You can strip them. L strip gets rid of leading. R strip gets rid of trailing, or on the right side, white space. Okay, this is just an example of what I said on splitting. Okay, method to break a string into its component parts, a list. Okay, the default is to split on white space. For now, that's all we care about, is we're going to split on white space. And here are some more examples of what happens if you don't want to split on white space. But I promise you, you won't have any issues. You won't have any need to split strips, to split strings on anything other than white space until after the first exam. So don't worry about that for now. I won't put that on the exam. Strip removes white space, gets rid. L strip, R strip, just strip gets rid of left and right both. And again, like I illustrated the score of Kansas City, San Francisco, this does not get rid of blank spaces between the words in a string. You keep what's called the internal white space. You do not strip off the leading blanks and the trailing blanks. So really quickly, this has been, we're actually a little bit ahead of time for once. This has been a completion of list operations that you need to know about, because you'll be getting a lot of practice with the next couple of labs, the next couple of homeworks. And this has been an explanation of how, in some cases, strings are not lists, but in some cases you can treat a string as if it were a list. Okay. And so these are illustrations on things you could do, and we will build on those. Now, Wednesday's lecture, we get into loops, and this is where we can take advantage of all this list functionality, and we can process all the elements of the list one element at a time. We can write a program that goes through and takes each state out of that list of states and does something with it, and we can build it out. And so that's Wednesday's lecture. Again, homework 3 will be available in a little bit as soon as I get it published to GitHub. And the homework 2 is due at midnight. 3 will be due next Monday at midnight. If you have any problems with submitting it, let me know. Hopefully we have everything set up. Again, the majors classes, it was due last week. After Wednesday, I will be exactly caught up. After Wednesday, we will actually be a little bit ahead of the majors classes and lectures. We'll cover all the material. But I wanted to cover a certain set of things before we got this far. That's why you've been getting your homework through later. At any rate, I will stay on and answer any questions. But if you're done, if you're satisfied, you can go ahead and log off, and I will talk to you on Wednesday. Again, as always, Discord, do whatever you need. Go ahead.